Hello everyone. In this video, we'll be discussing one easy and one hard problem of CodeDrift, linked list, stacks, and queues. Let's start with the easy problem first. So what the problem says is, there is a line and ticket counter of n people. Each person has some patience level AI, which if reaches 0, the person leaves the line. Also, it takes BI amount of time to process the ticket for the ith person. And each unit of time, patience level of each person is dropped in the line is dropped by 1. So the ticket counter wants to know how many customers who will leave the line. Note, if the person reaches the front just at the moment its patience reaches 0, it will not leave the line. Okay, let's try to understand it with an example. Let's take an example here. Let's say AI, that is my patience level, has some values 1, 7, 6, and 5. And similarly, BI, that is the time taken to processing time for every ticket, is the first person takes 3 units of time, second again 3, fourth, third again 3, fourth takes 1 unit of time. So let's understand it like this. So if there is something like a number line here, this is 1, this is somewhere 5, this is 6, and this is 7. And the first person leaves here, the second person leaves here, sorry, second person leaves here, and then the third person leaves here, and the fourth person leaves at this point. So the first person enters. When the first person enters, he takes 3 units of time. So time till 3 is blocked. The first person is processed. Then second person comes into the counter, comes on the counter, and the second person is processed because the patient's level is way high. He can still wait. So second person takes again 3 units of time. That is, till this point, the patient's level has reached. And at the same time, the fourth person with the patience level 5 would have already left, and the third person is at the counter. Third person patience level is now 0, and that means he can still take the ticket there. So if you look at it, only one person left the counter, that is the fourth person. So my answer should return 1. It's a straightforward question that every person inside of this array will be processed from the first to the last, and every time we'll keep on adding the patience time taken by each player into my total time. So at any time, if my total time is greater than the patience level of that person will leave. Let's look at the code of this problem now. Let's look at the code of this problem. So we given two arrays, that is my patience level and my time taken to process one ticket. Initially my time is 0, and my answer, that is the person of people who have left, is 0. So I'll go through my entire array. I'll check if my time is greater than the patience level of that particular person. If yes, I increment my answer and I continue. I'll go to the next person. If not, I'll add that I'll add the processing time taken by that person to my total time. And at the end, once this loop ends, I'll just return the answer, that is the total people who have left the counter.
Okay, let's look at the hard question now. The question says that you need to maintain a queue that is initially empty. You will perform three types of operation. The type 1 operation is you'll add a number x to the queue, that is add a number x to the last of the queue. The second operation is remove the least recently added number from the, that is remove from the start of the queue. The third type of operation is consider the current numbers in the queue and the maximum size of a subset of numbers in the queue whose sum is x. If there is no subset, return -1. And it says that a subset is defined as a sequence that can be obtained by removing some possibly all elements from the queue. Okay. Let's try to understand it with an example. Let's take an example where A is equal to 1, 3, 1, 1, 1, 1, 2, 0, and then we have 3, 2. So initially my queue looks something like, so first I have a query of type 1 that is insert 3 inside of my queue. Then I have another query of type 1 that is insert. So I'll insert 1 inside of my queue. Another insert query of type 1 that is again insert 1. Then I have a type 2 query that is remove one element from the start of the queue. So 3 gets removed from the queue. Now I'll get another query, type 3 query, that is find the subset whose sum is equal to 2 and the size should be maximum. So the maximum size I can achieve to get a sum of 2 is, I'll take both of these elements. So 1 plus 1 is 2. So the size is, 2 elements are there. So size is 2. And I'll keep on updating my answer with size 2. Since there's only one query of 3 of type 3, so I'll just return 2 inside of here. Let's look at the time complexity for this operation, for the normal queue. So every time I add some element and then I can query for the element. I'll again add type 1 query and then query. So if every time I add and query, that is fine because we know how to find this subset thing. We know that we can do using DP, and using DP, my only states that's going to be changing is if I either take this element that is DP of I take this element and want to achieve sum of x minus AI, or I won't take this element that is DP of I plus 1 and I'll keep the sum as it is. This is of I comma sum, let's say x. So if you look at it, the only thing the DP depends upon is my previous state only. Okay. So if I'm adding some element, that means only my previous states are required. So I can just do it like this only. Every time I have a type 1 query and I get a type 3 query, I only have to check this, my last query, my last update. Then again, if I have some additions, type 1 queries, and I have a type 3 query, so this type 1 query will only depend upon this query. Only this type 3 query will only depend upon this last type 1 query. So I can just do an A of x, where A is the size, x is the total sum, maximum x value, maximum sum that I can search for. And every new update query will be of x only, O of x. Every new update query is of x. So the total time complexity will be A of x. Sorry, A of x, big O of A of x. But the problem occurs if I have a delete query inside of it. If I want to delete the element, then this state is changed. Similarly, if this state is getting changed, then the next is getting changed, and so on. All states are getting changed. So in that case, if I get a new, if I add an element at the last, then I'll have to change the entire table. That is every time A of x as an operation. I'll have to do this entire thing again. So how many times I might have to do it? It becomes O of A square x. So A's value is 10 raised to the power 5. So this will definitely give me a TLE since it's 10 raised to the power 10 into x. So better way to do it is instead of implementing a queue with the queue, will implement a queue using a two stacks. So we have two stacks, a stack 1 and a stack 2. So what the stack 1 do, it only takes care of add queries, whereas stack 2 takes care of remove queries. So how does it actually work is, if every time I get add query, I'll add that element here. And every time I get a remove query, I'll remove it from here. And if this stack is empty, I'll take all the elements from here and add them here. And I empty this stack if into my stack 2. And then I remove the element that's from the top. That is the elements that was least frequently added. And then again I follow the same procedure. If this stack is empty, I empty into the other one, in the stack 2 one. Then I'll have some elements here. And then if in the next time I get an add query, I'll add it here. If I get a remove query, I take it from here. So this way, adding a new element to my stack, it's again O of X operation, because I just have to check my previous state. Similarly, removing an element from my stack is again O. It's an O of 1 because I don't have to change anything. I can just remove it from the top. This element can be removed from the top. I don't need to change it because this state depends upon the previous only. So I need not change the next one. So I can just do it in O of 1. So the total time complexity would be, average time complexity would be O of A into X. See how this will work for a given example. Let's take the example again. So we'll have 1 3 1 1 1 1 2 0 3 2. So initially my stack 1 will be something like this, and this is my stack 2. In my stack 2, I have an insert query, that is type 1 query. I'll just insert 3 into it, and since I'm inserting 3, I'll also insert my DP state with. So initially my DP state would be 0. It would something look like this initially. And when inserting 3, I'll just check, can I form 3? Yes, I can. If I take 3, can I form a 1? No. So it remains -1. Similarly, minus 2 also remains a -1. Can I make a 3? So I'll check for 3 minus the current element, that is 3 only. So I'll check for 0. Yes, I can make a 0 with 0. So I'll just update it with 1. And then -1 and a -1 and so on. So they will have a D state like 0, -1, -1, 1, and then again -1, -1, so till 350, because the maximum value of X can be 350. Now I look at the next query. Next query is again of type 1. So I'll insert 1 and I'll check my previous DP table, that is this one, and I'll see if I can make a 0 from 1. No, it remains the same as it is. I'll check at 1. Can I make a 1 minus 1 as 0? Yes, I can make it. I'll update it with 1. Similarly, -2 will not be updated because the previous 2 minus 1 is 1, that is -1 previously, so I cannot make it now. I'll check for 3 now. Can I make a 3? So to make a 3, I'll have to check for 3 minus 1, that is 2. It's a -1, so I cannot make it. So take the maximum of this value and whatever value I can make. So it's +1. Then I'll check for 4. Can I make a 4? So to make a 4, I'll have to check 4 minus 1, that is 3. Yes, I can make a 3 with 1 more. I'll have one more element inside of it and make it a 4. So it becomes 2. And then a minus 1, so on, because 5 cannot be done because I cannot make a 4. So this time I have 0, 1, minus 1, 1, 2, minus 1, so on, and minus 1. So next query is again a one query. So I'll have insert 1. That means I'll again form this DP table for this one and just check for the previous table. So I'll have 0. Can I make a 1? No. Yes. Then can I make a 2? To make a 2, I'll have to check for 2 minus 1. That is 1. So plus 1 is 2. I'll take a 2 here. Then can I make a 3? To make a 3, I'll have to, can I make 2? No. So I'll take the maximum value. Then can I make a 4? To make a 4, can I make 3? I can make 3 with one element. I'll add one more and it becomes 2 here. Make 5. I'll have to, can I make a 4? I can make 4 with 2 elements. I'll add one element, that is, it becomes 3. And the next element remains minus 1 because I cannot make them like that. So let's update this table as well. So 2, 1, 3, 1, 2, 3, and minus 1 and 1. So the next operation is a type 2 query, that is a remove query. I'll check my stack 2. Since my stack 2 is empty, the operation we discussed will do is I'll empty stack into the stack 2. So this will become 1, 1, and 3. And the table. And while inserting inside of my stack, I'll keep on updating my stack table here. So I'll just update my stack table this time. While inserting a 1, I'll have something like 0, the initial stack DP table I had. 0, 1, 2, 3, 4, 5. I'll check, can I make a 1 with 0? No. Can I make a 1? Yes. So I'll have to check, can I make a 0? Yes, I can make a 0 with 0 elements. So it becomes 1. And then it's all minus 1 because all of the previous elements I cannot. So the table here is 0, 1, minus 1, minus 1, and so on. Similarly, I check for the next one as well. Can I make a 1? Yes, I can make a 1. Can I make a 2? I'll check for 2 minus 1, that 1. I can make 1 with moves. I can make 2 with adding this 1 as well. So it becomes 2. And again, the next one remains minus 1 because I cannot make all of those. So 0, 1, 2, minus 1, and minus 1, and so on. Now I'll check, can I make a 3? To make a 3, I'll have to check, can I make, can I make a sum of 3? Yeah, let's check. If I take the element t, that means I'll have to check for 1 minus 3, that is minus 2. I cannot make it. So it remains the maximum of this. Then 2, yeah, so 2 is 2 minus 3 is minus 1. So I'll take the maximum, it is here, and then I'll check if I make a 3. To make a 3, I'll have to check 3 minus 3, that is 0. Can I make a 0? Yes, I can make 0 with 0 moves. So I'll add 1, it becomes 1. Now I check, can I make a 4? To make a 4, I have to check 4 minus 1, that is 1. Can I make a 1? I can make 1 with with that one element. So I'll add one more element and it becomes 2. I'll have to check, can I make 5? So 5 can be, I'll have to check for 5 minus 3 as 2. So can I make a 2? Sorry, I've checked here. Can I make a 2? Yes, I can make a 2 with 2 elements. I'll add one more element and it becomes 3. And so the elements remains minus 1 since I won't be able to make any of them. So it becomes 0, 1, 2, 1, 2, 3, minus 1, so on. And this tag becomes empty now. And now I'll perform a remove operation, that is type 2. I'll just remove this from here. and then I move to the next operation, that is type 3 query, that is find the subset to find a sum of 2. If my stack, there can be three cases, that is stack 1 is empty, or stack 2 is empty, or both of them full. Was full and stack 2 was not full, like they had some elements. Stack 2 also had some elements. Stack 1 is empty, I can just check the topmost DP table of stack 2. Similarly, if stack 1 is empty, if stack 2 is empty, I can check the topmost element of stack 1. If either of them is empty, then I'll have to check for all the sums from 1 to x. And in, let's say in stack 1, let's call it I from 0 to x. Then in stack 1, I'll just check the maximum I can use to find, stack 1. I'll find if I can from I from it. And in stack 2, I'll check if I can make, x minus I from it. And I'll add it. And I keep on getting my answer. Let's say answer initially 0. So my answer becomes something like answer is equal to max of this, comma, the previous answer that I have. And I check for all the sums in that case. Okay, so let's look at the code now. Okay, let's look at the solution now. So so the solution is in Java and cannot have, instead of having a array list or a stack, something like this with the element and the DP table. I'm storing this DP table inside of my L1 or L2, depending upon which stack I am at. If I'm at stack 1, I'll go with L1, and if I'm into stack 2, then its DP table, respective DP table will be stored in L2. So what I have done is make a push operation. I'll just pass my previous DP table and the element that I want to push. Then I'll just create an array list, and what I'll do is I'll update the array list with respect to my previous DP table. Once that is done, I'll go from x to the 350, that is from the value, that element that I'm including, until the maximum value that I can have, and I update my DP table with respect to it. I'll update it with the maximum of if I take that element, or if that was a previous element, the previous value that I have been stored. But that's only possible if I minus x is a positive number, because if it's a negative one, that is I cannot form that element. So add 1 doesn't make any sense there. If I cannot add it there, then I'll just keep the -1 as it is and just move ahead. Okay, let's look at how we are storing it. I'll have something like a starting, that is if no element is inside of my array list, then I'll have this state as starting state. So I'll update it, I'll add a 0, and then for the rest of the elements I'll have a -1. So I'll just created this here. If no element is here, my DP table should look something like this. That's what I've created. And then I'll just make an array list for storing my answer that I'll return at the last. I'm creating my stack 1. I have created my stack 2. For stack 1, I have created L1, which will store the DP table for stack 1, and for stack 2, I have created the stack L2 that will store the DP tables for all their respective ones from stack 2. And I'll go from 0 to n with all the queries. So there are 3 types of queries. If the type is of type 1, I'll just push it inside of my stack, and if my stack 1 was empty, that is my L1 have no DP state, then I push starting DP table inside of that. Else I'll just push with respect to my previous DP state, my current element pushed into it. The next condition is if it is a remove query. If it is a remove query, I'll go to my stack 2, check if stack 2 is empty. Then I'll for all the elements inside of my stack 2, I'll push all the elements to the stack 2, and why this L2 is not, if my L2 is empty, that is there is nothing inside of my L2, then the same thing I'll use the starting DP table, or else I'll use the previous element that is already there and use its DP table. And once all the elements are inside of my stack 2 from stack 1, I'll pop the last element from my stack. Sorry, I'll once I have moved one element from stack 1 to stack 2, I'll remove that element from stack 1 and I'll remove its DP table from L1. And at the last, I'll just move that element from my stack 2 and its respective DP table from L as well. There's a third case if the to find the maximum subset. To find the maximum subset, I'll check if L1 and L2 both are empty. Then in that case, I'll enter a -1. That is, there is no element inside my stack in my either of the stack. I can return a -1. Let's say if L1 is empty, that is stack 1 is empty. If my stack 1 is empty, I'll look into my stack and take the maximum of that stack 2 element. Like topmost will give me the answer if I can have that element or not. If not, let's say if L2 is empty, the second case is stack 2 is empty. Stack 2 is empty. In that case, I'll just look into my stack 1 and get element from the topmost element. Otherwise, it means either my stack 1, either my stack 2 were empty, both had some element into it. So what I'll do is I'll look for all sums from 0 to the sum I want to see, and I take the maximum of all the possibilities that I can have. That is, first I'll have I from here and then x minus I from here, and this is from stack 1, this is from stack 2, and I take the maximum possible, uh, maximum size of the subset that I can have, a combination of these two. What the maximum I get, I'll store it here. At the last, I'll just add that particular element inside of my answer and I'll just return the answer. Thank you.